The directions say to solve each exponential equation. Recall, if a to the x is equal to a to the y, then x equals y. Note, a is greater than 0 and a doesn't equal 1. We're going to need this. Let's take a look at example 1. Suppose 2 to the x plus 2 is equal to 64. And so here's the goal. Can I rewrite both sides of the equation so that they have the same base? The answer is yes. So I'm going to leave the left side alone and write 2 to the x plus 2. On the right side, it turns out 64 can be written as 2 to the 6th. But if 2 to the x plus 2 is equal to 2 to the 6th, x plus 2 has no choice but to equal 6. And so all I have left to do is solve for x. So x plus 2 minus 2 is equal to 6 minus 2. The 2's cancel, and we can say x is equal to 4. And that's how you do example 1. Let's take a look at example 2. Suppose 8 to the x is equal to the square root of 2. So, a couple things to note. 8 is equal to 2 to the 3rd. Square root of 2 is equal to 2 raised to the 1/2 power. So 2 to the 3rd raised to the x is equal to 2 to the 1/2. So just like in example 1, the goal is to rewrite both sides so that they have the same base. So 2 to the 3x is equal to 2 to the 1/2. But if 2 to the 3x is equal to 2 to the 1/2, 3x has no choice but to equal 1/2. So we can say 3x equals 1/2. Now, there's a couple ways you can go about solving this. One way is to get rid of the fraction. And to get rid of the fraction, I'm going to multiply both sides by 2. And if you don't mind, I'm going to write 2 as 2 over 1. 2 times 3x is 6x. And then 1/2 times 2 over 1 is equal to 1. But if I divide both sides by 6, I can conclude that x equals 1 over 6. That's how you do example 2. Let's take a look at example 3. Suppose 3 to the x is equal to the cube root of 9. Now, we can say 3 to the x is equal to 9 raised to the 1/3 power. Question still remains, can I rewrite both sides so that they have the same base? The answer is yes, I can. 9 can be written as 3 squared. So 3 to the x is equal to 3 squared raised to the 1/3 power. And so this tells me 3 to the x is equal to 3 raised to the 2/3 power. Well, if we look, 3 to the x is equal to 3 to the 2/3. So x has no choice but to equal 2/3. Here, let's write that over here. So x equals 2/3. And that's example 3. Let's take a look at example 4. suppose 7 to the 5x is equal to 1. But let's recall something. If I take 7 and raise it to the 0 power, I get 1 back. And so 7 to the 5x is equal to 7 to the 0. So this tells me 5x has no choice but to equal 0. Dividing both sides by 5, we can say x equals 0. That's example 4. Let's take a look at example 5. Suppose 5 to the absolute value of 2x minus 3 is equal to 25. So we're going to start to get a little more difficult. So the goal is the same in that you want to rewrite both sides so that they have the same base. So 5 to the absolute value of 2x minus 3 is equal to 5 raised to the second. And so that tells me the absolute value of 2x minus 3 is equal to 2. Now, I ask myself the following. The absolute value of what will produce 2? And when you look at absolute value, here's 0. And if I go out a distance of 2, I land over here. So the answer here is 2. But remember, I can go to the right of 0 or I can go to the left of 0. In either way, you're traveling the same distance. And so I can hop over here and land on negative 2. Okay, either way it goes. And so the what in this case is 2x minus 3. And so what I can say is two things. I can say 2x minus 3 will give me 2, or 2x minus 3 will give me negative 2. So we need to solve for x in both cases. Now, if 2x minus 3 is equal to 2, then 2x minus 3 plus 3 is equal to 2 plus 3. So the 3's here cancel, and we get 2x equals 5. So x equals 5 halves. That's one of the solutions. Or 2x minus 3 equals negative 2. So if I add 3 to both sides, we get 2x minus 3 plus 3 is equal to negative 2 plus 3. But these 3's cancel, and we get 2x equals 1. That's what negative 2 plus 3 is. If I divide both sides by 2, I get x equals 1 half. So the answer to example 5 is the set containing the solutions 5 halves and 1 half. And that's example 5. Let's take a look at example 6. Suppose 4/9 raised to the x is equal to 3 halves raised to the negative 6. Now, there's a law of exponents here. If I take a over b and raise it to the negative n power, it turns out that this is b over a raised to the nth power. So if I take the reciprocal of a over b, I have to change the sign of that exponent. And so what do we get? in our case, we get 4/9 to the x is equal to 2/3 raised to the 6th power. Now, 4/9 is equal to 2/3 raised to the 2nd. So I'm going to get 2/3 raised to the 2nd to the x is equal to 2/3 raised to the 6th, which says 2/3 to the 2x is equal to 2/3 to the 6th. Okay? Notice how we have the same base on both sides of the equation. So what that tells me is that 2x equals 6. Divide both sides by 2 and we get x equal 3. 6 divided by 2 is 3. And that's how we do example 6. So let's take a look at example 7. Suppose I had 7 to the 5x over 2 is equal to the 5th root of 343. Okay. Now, I'm going to suspect that 343 is divisible by 7, because what did I say in the beginning? We're going to need to be able to rewrite both sides so that they have the same base. If you cannot rewrite both sides so that they have the same base, we have to introduce a different way to attack this problem. Okay? And that could be done in another video if needed. Now, 343 divided by 7. Well, 7 goes into 34 4 times. 4 times 7 is 28. Okay? If I subtract, I get 6, bring down the 3. 7 goes into 63 9 times. So it does look like 343 can be written as 7 times 49. But I already know 49 is 7 times 7. So it looks like we're good to go there. So on the very next line, I'm going to write 7 to the 5x over 2 is equal to the 5th root of 7 to the 3rd. So 7 to the 5x over 2 is equal to 7 to the 3/5. And if 7 to the 5x over 2 equals 7 to the 3/5, we can say 5x over 2 is equal to 3 over 5. And this is a nice cross multiplication problem. So what we can say is 25x is equal to 6. Do you guys see that? 5x times 5 is 25x. 2 times 3 is 6. So I'm cross-multiplying and set equal the results. And then if I divide both sides by 25, I get x equals 6 over 25. And that right there was example 7. Let's take a look at example 8. Suppose I had 1/2 to the 2x plus 2 divided by x plus 2. And I'm going to set this equal to 2. So 2 to the negative 1 raised to the 2x plus 2 over x plus 2 is equal to 2 to the 1st. Okay. Now, when you have a power raised to another power, you essentially multiply the exponents. And so 2 raised to the negative of 2x plus 2 divided by x plus 2 is equal to 2 to the first. Now I can set the exponents equal to each other. So the opposite of 2x plus 2 over x plus 2 is equal to 1. And then, if you don't mind, I'm going to move that negative over to the other side. And so I get 2x plus 2 divided by x plus 2 is equal to negative 1. Now I get to move x plus 2 over to the other side. So 2x plus 2 is negative 1 times x plus 2. But I need to get rid of those parentheses. And so I'm going to distribute the negative inside. So I get 2x plus 2 equals negative x minus 2. Okay. So far. So let's write that on the next page. So 2x plus 2 is equal to negative x minus 2. Subtract 2 on both sides. Okay. Now, this says 2x is equal to negative x minus 4. And then from here, I'm going to add x to both sides because I want x's on one side, number on the other side. And so 3x is equal to negative 4. And if I divide both sides by 3, I get x equals negative 4/3. And then one thing I would like to mention is a way to check this, and I didn't check this for any of the examples, is I can go back to the original equation and replace x with negative 4/3. And you will see in the end that you will get 2 back. And that was example 8. So let's take a look at 2 more examples for this video. So on example 9, suppose I give you the following. 8 to the x times 2 to the 6x is equal to 4 to the 2x plus 10. Okay, 2x plus 10. Now, remember 8 is 2 cubed. So I'm going to write this as 2 cubed to the x times 2 to the 6x. And that's on the left side, equals 4 is 2 squared, raised to the 2x plus 10, like so. So 2 to the 3x times 2 to the 6x is equal to 2 raised to the 2 times 2x plus 10. But remember, a to the m times a to the n is a to the m plus n. I've had to use this multiple times. So 2 to the 9x is equal to 2 raised to the 4x plus 20, like so. Now we've rewritten both sides so that they have the same base. So 9x equals 4x plus 20. Subtract 4x on both sides. And what we can say is 5x equals 20. Divide both sides by 5, and we can see that x equals 4. And that's how we do example 9. Let's take a look at one more example for this video. We'll call this example 10. In example 10, suppose we had the following. 2 to the 1 minus x squared times 2 to the 2x is equal to 64 raised to the negative 1. Goal remains the same. Rewrite both sides so that they have the same base. So 2 to the 1 minus x squared plus 2x, right? That's the left side. 64 is 2 to the 6th. So I'm going to take 2 to the 6th raised to the negative 1. So 2 to the 1 minus x squared plus 2x is equal to 2 raised to the negative 6. Well, I can set them both equal to each other, right? So 1 minus x squared plus 2x is equal to negative 6. Now, I'm going to subtract 1, add x squared, and then subtract 2x. And I just going to do the same thing over to the other side. So if I add x squared, subtract 2x, and subtract 1. I hope that's okay to put it in that order. Now, okay, on the left-hand side, we get 0. We get 0. On the right-hand side, we get x squared minus 2x minus 7. Which I cannot factor over the integers. Okay? And so here, a is 1, b is negative 2, and c is negative 7. So applying the quadratic formula, x equals the opposite of b, which is 2, plus or minus the square root of b squared, which is 4, minus 4 times 1 times negative 7. So it's b squared minus 4ac, all divided by 2, 2a, which is 2. So x equals 2 plus or minus the square root of 32 divided by 2. But the square root of 32 is equal to the square root of 16 times 2, which is 4 times the square root of 2. So x is 2 plus or minus 4 times the square root of 2 divided by 2. And if I'm your teacher, I would want you to simplify. And so therefore x is 2 over 2 plus or minus 4 square root of 2 divided by 2 if I split the fraction. And so x is 1 plus or minus 2, right? 4 divided by 2 is 2, times the square root of 2. And so we have two solutions. We have 1 minus 2 times the square root of 2, and we also have 1 plus 2 times the square root of 2. Okay, and that'll do it for this video. We did 10 examples of solving exponential equations. Okay, thank you.